Jai Hind, welcome to the course Network Analysis and Synthesis, and today I am going to discuss about some university questions related to Unit 1, that is about the graph theory. In earlier video lectures, I have recorded all the details of this unit, but today I am going to take up some numerical problems that has been asked in the university examinations. So, just first problem is write the incidence matrix and cut-set matrix for the network shown in figure. Take 2, 4, 5 as tree branches. The first draw the network. So network is like this. Then we have so this is of 5 ohm, this is of 4 ohm, 4 ohm, 5 ohm, 4 ohm, 5 ohm, and 10 volt. Say direction is also given, so the network is oriented, and branch numbering is given. So this is branch number 1, this is branch number 2, and this is branch number 3, this one is branch number 3, this is branch number 4, branch number 5, and this is branch number 6, and these are the nodes 1, then this is node 2, node 3, and node 4. So in the circle, they are the nodes, and the bracket, they are the branches, and the node network is oriented, and the orientation is like this. So this is the direction is like this is like this one, then this is and this orientation of this branch 4 is like this. So this is the network, given network. So the what is the first step is step 1. Draw the oriented graph for the given network, because you are required to write the incidence matrix and cut-set matrix. For the cut-set matrix, you have to take the 2, 4, 5 as a tree branches. So we'll discuss later on. First we'll go for the incidence matrix. So for the incidence matrix, we must have a oriented graph for the given network. So first draw the oriented. So this is your node 1, branch 1, then it is node 3, so this is your branch number 1, this is branch number 2, this is branch number 3, branch 4, branch 5 and branch 6. Node 1, 2, 3 and 4. So this is oriented graph for the given network. For the given network. Okay. The first step is, if the network is not oriented, so first you have to orient the networks, assign the branch numbers, and then draw the oriented graph. So from the oriented graph we can write the incidence matrix. So for the incidence matrix, just we go to the other pages. So incidence matrix, say this matrix is AA. AA means includes all the nodes. So AA is the, here we have the number of rows. Number of rows corresponds to number of nodes, and the branches are 6, so there are 6 columns. 1, 2, 3, 4, 5, 6. Okay. So branch number 1, we see that the orientation is from 2 to 1. So from 2 to 1, so here we have the -1, and 2 we have the, and the other is 0. For the branch number 2, the orientation is from the node 1 to towards 3. From node 3 to towards 1. So 1 will be -1, then 0, then 1, then 0. Now come to the branch number 4. It's oriented from 2 to 3. So oriented away from the node 2 and towards node 3. So it is branch number 3. Branch number 3 is from 1 to 4. Sorry. Branch number 3 is from 1 to 4. So 1 to 4. So 3 is 1, and this is 0, 0, and 4 is -1. 4 is -1. Come to the branch number 4. So it is 2 away from the 2 and towards 3. So it is 4 is 0. Then away from 2, so it is 1. Towards 3, so it is -1. Then 0. 5. So from 3 to 4. So 3 to 4, so 1, 2 will be 0. 3 will be +1, 4 -1. And 6. 6 is from 2 to 4. So 2 to 4. So 2 to 4 is, we can write as 0, 1, 0, -1. I can draw the graph here. We can, for the convenient, we can draw the graph here. This is 1, this is your 2, this is your 3, and this is your 4. So it is 1, branch number 1, branch number 2, branch number 3, branch number 4, branch number 5, branch number 6. So look at the branch number 1. So it is in between 1 to 2, and orientation is away from the node 2. So away from the node 2, so it is plus 1, and incident at node 1, so it is minus 1, and we can other, and the 3 and 4 0, and we can see the summation of the columns should be 0. So just we can check the summation of columns should be 0. Okay, look at the branch number 2. It is 3 into 3 1. So away from the 3, so plus, and towards 1, so minus. 3 we can see 3 1 and 4. Away from the 1, so it is plus 1, and 4 minus 1. 5 we can see the 4 2 and 3. So away from 2, so plus, and incident at 3 towards 3, so it is minus, and remaining 0. 5 similarly, 5 we can write 3 4. So 3 plus, 4 minus, and 6 2 4. So 2 is plus and 4 is minus. And for the check we can see that the summation of the column is 0. So it is the incident matrix, so we can say the complete incident matrix. If you are required to write the reduced matrix, reduced incidence matrix. So what you have to do, we have to remove one row from the complete incidence matrix, and the row corresponds to the reference node. So we can remove the row 4. So this is A. So this is incident. It is denoted by A. A means, small a means includes all the nodes. So it will be like this. So 1 2 3, and branches, number of columns will be 6 4 5 6. So we can write minus 1 1 0, minus 1 0 1, then 1 0 0, then 4 0 1 minus 1, and 5 0 0 1 6 0 1 0. So this is the reduced incidence matrix. We have removed one row from the complete incidence matrix. So this is the first part of the problem. Write the incidence matrix on reduce. It is not mentioned, so it is better to write on both the matrices A and A. We can get the reduced matrix from the complete incidence matrix. First you have to write the complete incidence matrix, and then after you have to write the reduced incidence matrix. Now there is another problem. Now for the cut set matrix. For cut set matrix, take 2 4 5 as a tree branches. Take 2 4 5. Take 2 4 5 as tree branches. So you have to select a tree. So tree is like this. 2. So this is the 4. This is your 5, and this is your 2. So these are the tree branches. So remaining branches are links. If you select a tree, the remaining branches are links. So this is your 6, this is your 1, and this is your 3. Okay. Now we have to write the cut set matrix or fundamental cut set matrix, because once we take the tree, so we go for the fundamental cut set matrix. fundamental cut set matrix. This is denoted by QF. So how many cut sets are there? Number of cut sets are equal to the number of twigs. So fundamental cut sets, the matrix will be the fundamental cut sets. So how many fundamental cut sets? The fundamental cut set will be fundamental number of fundamental cut set equal to number of tree branches. It is known as twigs. So branches of a tree are called twigs and branches of a core tree are called links. So there will be 3 cut sets because there are 3 twigs, and the orientation of cut set will be as per its defining twigs. So orientation of the twig will be like this. So this is your C2 because C2 for the twig 2, and the orientation of this will be like this, the twig's direction, and of this. So this is your C4, and this is your C5. C5 means for the twig 5. So in the fundamental cut set matrix, number of rows equal to number of fundamental twigs. So QF is say C2, C4 and C5. Columns will be equal to the number of branches. So say 1, 2, 3, 4, 5, 6. Now come to the C2. So C2 1, 2, 3. So direction of branch 1 is same as the direction orientation of the C2. So it will be 1. 2 will be 1. 3 it is the against the direction of the, so it is -1. 4, 5, 6 they are not involved, so remaining elements will be 0. Come to the C4. So C4 have 1, 4, 6. So 1, 4, 6 all positive. 1, 4 and 6 all positive. Other branches will be 0. Come to the C5. C5 involves 3, 5, 6. And the orientation of all 3 branches 3, 5, 6 are same as its defining twigs. Or this is your cut set. So 5, 6 and 3 all will be positive. So 1, 2, 0, 3 will be 1, 4 will be 0, 5 will be 1 and 6 will be 1. So this is the fundamental cut set matrix. Okay. If you are required to write the cut set matrix, then you have to write the we have to see how many cut sets are there. So we, by definition, we know that cut set is a minimum combination of branches whose removal causes graph to be divided into two under the condition that by restoring any branch of the combination, the graph should become connected. So this is the condition. So there may be 6 cut set will be there, but fundamental cut set will be the equal to the number of its defining twigs. So there are 3 twigs, so there will be 3 cut sets, so 3 row. So the dimension of this matrix will be 3 by 6. Network shown in the figure give fundamental cut set matrix and hence find the KCL equations. So the network is like this. It is like this. It is also in the AKTU examination 24-25. This question has been asked. So this is the given network. It is a current source of 1 ampere current source, 2 ohm. This is branch number 1, this is branch number 2. It is not given, you have to just mark the branch numbers and the nodes, and you have to orient. So this current sources accompanying this branches, so direction of this branch will be like this. Then we can orient these branches like this way and this way, and we can mark the number of nodes. So number of nodes will be 1, 2, this, and we have the one reference node, say the 3, reference node 3. So now we can draw the oriented graph. Draw the oriented graph. So it is like this. This is your 1, this is your 2, and this is your 3. Node 3. So 1, 1, 3, then 2, 3, then again one branch. So this is branch number 1 between node 1 and 3, branch number 2 in between 1 and 2, branch number 3, 2 and 3, and 4, branch number 2 and 4. So 3 and 4 branches, they are in parallel. So here it is. Now you have to write the fundamental cut set matrix. So fundamental cut set matrix, you have to take the tree. Take a tree. If not given in the question paper. In this case, it is not given. I am taking 1, 3 as a tree branches. So this is your tree. This is 1 and this is your 3. So remaining branches are links. So it is your 2 and it is your 4. Now there are 2 tweaks. So fundamental cut set will be 2. So fundamental cut set will be, one cut set will be like this. So this is your C1, this is your C1, and another one will be like this. So the necessary condition will be 1 tweaks and remaining links. So this is another cut set. This is another cut set. So this is your C3. This is your C3. Involving branch number 2, 3, 4. 3 the tweaks and remaining 2, 4 are the links. So in the fundamental cut set, we have to select 1 tweaks and remaining links. Okay. Now fundamental cut set matrix, we can write QF is equal to C1. There will be 2 rows and C3. And columns will be corresponds to the number of branches. So there are 4 branches, so 4 number of columns. Now come to C1. C1 involves 1 and 2 and direction is. So C1 is along the tweak, along the cut sets, it will be plus, 2 is away, so it is minus 1, remaining 0. C3, 2, 3, 4. So 2 will be minus 1 and 3, 4 will be plus 1. So this is your fundamental cut set matrix. Now you have to use the KCL relationship. So using KCL relationship, we know that minus QF into IS is equal to QF YB QF transpose NVT. So what are this? Where IS is current source of the order B into V. So B is the number of branches, and QF, this is the transpose. QF is transpose of fundamental cut set matrix. Fundamental cut set matrix. And BT is twig branch voltage. So BT, we have the BT1 and BT3. So this is also a matrix. So there are 3 branches, 2 twigs, so BT1 and BT3. So now first you have to calculate the branch admittance matrix, because we have obtained this one. Then we have take the transpose of this, and we have to multiply these 3 matrices. So first we calculate the YB. So YB is a square matrix. So there are B into B. So there are 4 branches, so 4 columns and 4 rows. And now 4 columns, 4 rows and 4 columns. So in the branch number 1, the admittance is, impedance is given 2 ohms, so it is 0.5 mho of this, or remaining 0. Now the branch number 2, the impedance given is 1, so admittance will be 1, remaining 0. Branch number 3, it is 2. So it is 2, so it is 0.5 mho. Admittance will be inverse of the resistance, so it is 0. Now come to branch number 4, and impedance given is 1 ohm. So it is 0, 0, 0, and admittance will be reciprocal of the resistance or impedance, so it is 1. So this is your YB. Now we have to, what we have to do, we have to multiply all these three matrices. So QF, now QF YB QF transpose. I am writing a straight way, just you checked it. So 1 0 minus 1 minus 1 minus 1 minus 1 0 1 0 1. Take this is your QF, then YB, so it is 0.5 0 0 0, then 0 1 0 0, then 0 0 0.5 0 0 0 0 1, and now transpose of this. So it is 1 minus 1 0 0 0 minus 1 1 1. So we multiply, we can get this matrix is equal to, it is coming 1.5 1, then 1 and 2.5. So this QF YB QF transpose. Now we have to multiply, get the other matrix minus QF IS. So minus QF and IS. So minus QF is minus, then write the 1 0 minus 1 minus 1 0 1 0 1, and IS. IS means the current source. The current source is only in the one branch number 1. So it is 1, remaining branches containing no current source, so other will be 0. So it will be minus 1 0, so it is minus 1 0. So this, now we can put, so thus KCL equations are this minus 1 0 is equal to this 1.5 1 1 2.5 VT1 peak voltage and VT3. So using these equations we can get VT1 and VT3. So these are the, VT1 is the branch 1 voltage and VT3 is the branch number 3. So we can get other branches voltage just applying the loop analysis, KCL or KVL, and we can also find the current through the branches. So this is all about the questions.